Hi everyone. In this video, we are going to solve a problem. The problem name is binary tree pre-order traversal, and the question number is 144. This is a very easy problem, and by the question you come to know that we have to just do the pre-order traversal. But again, let's see the question. But this question say, given the root of a binary tree, return the pre-order traversal of its node value. Alright. So this is a tree. We have one root node, then it has right node that is 2, and it has left node that is 3. And we have to do what? Pre-order traversal. Alright. So what is pre-order traversal? So in pre-order traversal, we have to traverse first of all to the root value, then left side and the right side. Let me write here root, then we are going to move left side, then right side. So here guys, in this example, you can see root is nothing but 1. So first of all, we are going to take 1. Then guys, we have a left side. No, there is no left side. So we are not going to take, but we have to move right side. And here is 2. So we are going to take 2. And does this 2 have any left side? Yes, 3. Okay, so take this. Does 3 have left side? No. 3 had right side? No. So we are going to return 1, 2, 3. And in example also, you can see that we have answer 1, 2, 3. So this is pre-order traversal. If you still don't know, we will understand it with another example. But first of all, let's see what more this question say. So here guys, you can see that follow-up. Recursive solution is trivial. Could you do it iteratively? In this question, it want that I should solve the question using iteration approach, not a recursive approach. In recursion, there is a simple logic. Just first of all, print the root value, then move to the left direction, then move to the right direction, right? Let me show you how. We can just write a define function. In function, we can find our root. After that, we can say if not root, then return, right? Not root, return. And if root exists, then print the root dot value. We can say root dot value print. After that, call this function for left side, root dot left, and call this function for right side, one root dot right. This is what we do in recursion part. Just this three simple line of code can solve this particular problem. And guys, you can also check this code by just writing in your compiler. It will give the same value. But in this video, we are not going to use a recursion. So let me remove all these things. In this video, we are going to use iteration approach. That means we are going to use a loop. It doesn't matter, you can use a for loop, while loop, but we are going to use a loop, right? So how we can do this using a loop? First of all, let's take another example. So I'm going to write here first of all a logic, and here I'm going to write an example. So I'm going to take 1, then it's going to take 2, 3, 4, 5, and here 3 has only right node, that is 6. So this is our tree right now. The root value is nothing but 1, and these are leaf node. I hope you know about tree, right? Now guys, we are going to do pre-order traversal on this tree node. First of all, let's do manually. So we can say that first of all root will come, that is 1. After that what will come? Then we will come left side, that is 2. Then on 2 also we will come left side, that is 4. And now 4, there is no left side, move to the right side, and there is no right side, so it will come to 2, and 2 has a right side, that is 5. So 5, and there is no left side and right side on 5, it will come to 3. So we are going to take 3, then 6, right? We are moving left side, then we are moving right side, right? But before moving to left side also, we are taking a root value. That is clear, isn't it? All right, so this is our pre-order traversal, and we are going to achieve this pre-order traversal using iteration approach. How we can do this? Let's see that. We are going to use a stack. Fine. We are going to use a stack data structure. In a stack data structure, initially we will have our root, so that is 1. Fine. So we can see that guys, iterate our loop until and unless stack has at least one value, right? So we can write here condition while stack. That means any data present in a stack, at least one, that you can follow this particular loop, means it stack is going to return true. That is fine, right? So that condition true. Now guys, in condition we are going to take the value from this node. So here it is not a 1, it is a one node which has value 1. So we can say that find the value from this particular node. So we can say now current value is going to be particular node dot value, right? Fine. Once we find the value, we can append in our list. So we can say now result dot append that particular value, right? Once we appended the value, now we are going to check whether there is any left node exit and right node, because we are moving to left direction first, then right direction, right? So here guys, you can see that if I have a stack initially 1, and we have already popped this stack, that's why we took a value, right? So we can say stack is empty. Now if there left node exit, yes, there is left node exit, so we can write 2. This is right node exit, yes. But guys, you can see if we come to pop, then we will pop 3, right? Because this is at the top and stack follow the leaf order, last in first out. So we can't pop 3. Why? Because we want to pop 2 first. You can see after 1 we have 2 in our pre-order traversal. I hope you understanding it. So for that we have to do reverse. We have to first of all insert our right node, then we are going to insert our left node. I hope you understood it. So then we will pop it, that is going to pop a left side node. So in this code we are going to say if our node dot right exists, then you can push in our stack. So we can say stack dot push, and here we can write our node dot right. I hope you understood it. Now we are going to say if node dot left exists, then you can similarly push in our stack as well, right? Now what it will do? It will push 2 at the top and 3 at the end. Now again this condition will true. At least we have 2 data, right? So what we can say? Pop the top element. So we can say pop 2. Okay, we are going to insert it here. So let me write a 1 comma 2 now. Fine. And once we pop 2, we are going to check whether 2 has a right. Yes, 2 has a right. Now we are going to push this 5 node in our stack. So 5 come. And does 2 have a left? Yes, 4. So we are going to push 4 in our stack. Alright. Now guys, we are again going to pop it because we can see that there is 3 data present. This condition is true. So pop 4, insert in our list. Fine. So let me insert. Okay. Now guys, 4 has any right node? No. It has any left node? No. Okay. Come back. Now we are going to say we are going to pop 5. Fine. Here left node right 5. And does 5 have any right node? No. Left node? No. Okay. Now come back. Still there is a 1 data, right? Still this condition will true. So we can say pop 3. Okay. Let me write here 3. Fine. Now guys, we are going to check whether 3 has a right node. Yes. 6. It has any left node? No. Okay. Again, there is at least 1 data. Its condition will be true. Okay. Pop 6. So let me write a 6. Fine. And let me move from here. Does 6 has any right node? No. Does 6 has any left node? No. Okay. We will come same condition. And here guys, you can see that we have nothing in our stack, right? So this condition is not going to give us true. It is going to return us false. Now we have completed loop. And guys, we have this result. Fine. So we are going to return this result. And my bad, this is not going to be stack. This is going to be our result variable, right? Stack is our this, which we are using over here, right? So I believe guys, you understood the logic. How we are going to do? We are going to use a stack, take the data, push the right side, push the left side, and again go to the same condition until and unless we have at least 1 data in our stack. So now let's quickly move to the code and see how we can implement this particular logic. So here guys, first of all, what we are going to do? We are going to declare a variable result, which is a list, which will store our all the data in preorder traversal. And after that, we are going to say in our stack, push our root node, right? Fine. Initially, we will have root in our stack, but before that, we are going to check one condition, that is, if there is not a single node in our root tree, then what we can do? We can return an empty list, right? So we can say if not root, return an empty list. Fine. Now we know that there is at least one node present in our tree. So now we will follow it. We'll say while stack. Fine. And here we are going to pop it first of all. So we'll say node is going to be stack.pop. Fine. And we are going to insert that particular node value in our result, right? So we can say result.append node.var. Once we have inserted, now we are going to check whether there is right node exists. So we'll say if node dot right exists, then you can say stack dot append node dot right. Similarly, we are going to do for left side. If node dot left side exists, means left node exists, then we can say stack dot append node dot left. I hope you understood this. Now once we come out from this loop, we can say return result. This is a simple code which can solve this particular problem, which will help us to do a preorder traversal. So now let's quickly run this code and see whether it's working fine or not. You can see that it accepted all 3 cases. So now let's try to submit this code. And here we go. I believe guys you must understood this. If you still have any kind of doubt, you can ask in a comment section. And if you learn something new in this video, don't forget to hit the like button and subscribe my channel. Meet you in the next video.